Hello again, everybody. This is the second installment of Section 8, which is solving linear equations with fractions and also special cases. So I'm actually going to do special cases first, but good note-taking. We're going to title everything that we're going to be talking about today. So it's solving linear equations with fractions and special cases, but first focusing on special cases in algebra. I mentioned at the end of the last video that there are some situations where you won't simply be able to check your answer. So let's look at one such case. 3 parentheses 2x minus 5 close parentheses equals 6x minus 15. In looking at this, you might not notice there's going to be any problem whatsoever. Okay, so we're going to do this like a regular algebra problem. We're going to distribute to try to simplify the left side. This is going to give us 6x minus 15 equals 6x minus 15. Okay, now we're starting to see there's an issue because it's the same exact thing on both sides. When I go to try and move the variable, I'm going to be left with negative 15 equals negative 15. There's absolutely nothing wrong with that statement. Negative 15 does equal negative 15, but it doesn't explicitly say anything about x. And remember, when you're solving for x. So your final response has to be something about the solutions, about x. Well, let's think logically about this. Negative 15 will always equal negative 15. There's nothing that's ever going to make this not happen, okay, or not be true. So x could have been anything, and this would have happened, and this would stay true. And so if this is always going to be true, no matter what value x could have been anything, then the conclusion you make is all real numbers. That's what x could have taken on, could have been anything. Or if you prefer, you can say that it will have infinite solutions. Your word choice is really up to you, okay? But this is, you're going to pick one or the other. Okay, why is that? Let's put this in words. When the variable cancels out and you are left with a true statement, x could have been anything and it would still be true. This means x could be all real numbers or have infinite solutions. And like I said, you don't have to say both, just pick one. But you can't just stop here, okay? You have to make a statement about the solutions. Excuse me. So some of you might be asking, okay, this is what happens if it's true, but what happens if it's false? So let's do an example like that. Let's say that you're asked to solve 2 times 3x minus 5 minus 4x equals 2x plus 7. Now, again, you're not going to notice anything special about this. You're going to approach it like a regular algebra problem. So I'm going to have to simplify the left side. This is going to be 6x minus 10, copy down the minus 4x, equals 2x plus 7. On the left, I still see that I can simplify. So this is going to be 2x minus 10 equals 2x plus 7. I can already see what's going to happen when I try to move the variable. When I take away 2x from both sides, the x's are going to disappear. But this time, I'm left with negative 10 equals 7. This doesn't make any sense. Negative 10 doesn't equal 7, okay? Not in our world. So there's no value for x that is ever going to make this true. And since that's the case, this is when you say there are no solutions. There are no answers for x that are ever going to make this work, okay? Let's put in words what we just saw. When the variable cancels out and you are left with a false statement, there is no value for x that would ever make it true. So we say there are no solutions. And that's the statement that you make. Again, you are not done until you make a statement about the solutions. You can't just say that negative 10 doesn't equal 7. So these are the two examples of special cases. There's really no need to go through any more. If this occurs, now you know what to say, okay? Now you know the statement to make. So now we're going to talk about clearing fractions in algebra. So we all know that fractions do make things slightly more complicated, but I did say in a previous video that fractions are going to be our friends. So why are they going to be our friends? We actually have a really simple two-step method for getting rid of fractions in an algebra problem. This way we don't have to deal with them. So step number 1 is to decide on a common denominator among all fractions in the equation. And this is even regardless of like terms. That means you're looking all across the board, okay, both sides of the equation, and you're deciding on a common denominator. Once you decide on that number, and there will always be a common denominator, okay, think about what a common denominator means. It's a number that all of the denominators will go into evenly. So the simplest way to find one is just to multiply them together, and then they're guaranteed to divide into that evenly. But we'll talk about that in a minute. Once you decide on that number, then you multiply everything, all caps and underlined, everything in the equation by that number. And if you do this correctly, you are going to watch the magic happen, okay? This really is like math magic. So let's jump in with an example. I want to solve 3/4 x minus 7/2 equals 5/6. Now, I can do this the long way. I could just do algebra, add 7/2 to both sides. I'm going to have to figure that out, okay? Or I could use my calculator. Then I would have to either divide by 3/4 or multiply by the reciprocal like we saw in the last video. And I could do all that, but that seems more complicated. So I look at all these denominators, a 4, a 2, and a 6. What do they all divide into? I'll tell you a trick. The easiest way to do that is to take the largest of the denominators and start doing its times tables. Start looking at its multiples. So 6 times 1 is 6. That's not going to work because 4 doesn't go into 6. 6 times 2 is 12. 4 goes into 12, 2 goes into 12, and 6 goes into 12. So 12 is the winner, okay? Next, I'm going to take this whole side and multiply by 12, and I'm going to take this whole side and multiply by 12. You may find it easier to put 12 over 1 here. This way you can do the multiplication just straight across. Some of you won't need to do that, and that's okay. Then I'm just doing this distribution. I have to make sure that everything gets multiplied by 12. So this is going to be 36 over 4x minus 12 times 7 is 84 over 2 equals 12 times 5 is 60. The denominators aren't changing because I'm just multiplying the numerators by 12. You might be going, wait, you lied to me. There's still fractions here. Okay, but look at these fractions. Can they be simplified? 36 divided by 4 is a nice 9. 84 divided by 2 is a nice 42. And 60 divided by 6 is a nice 10. Sorry, 10. Look at that. All the fractions disappeared, which is exactly what we wanted them to do. The rest of this is basic algebra. Add 42 to both sides. 9x equals 52. Divide both sides by 9. Unfortunately, 52 is not divisible by 9. They don't have anything in common. So remember, we are not going to divide. We're going to leave it the way it is because this is considered exact form. Okay? And just like always, you could take this and you could plug it in to the x in the equation and then make sure that both sides balance. Okay? If you are going to type in fractions in your graphing calculator, okay, I recommend putting in parentheses and then doing 3, for example, 3/4. We're doing 3 divided by 4. You're just doing the regular division symbol, all right? That's going to give you 3/4, okay? Now, since I'm going to be performing the check here, right, I'm going to do 3/4 times 52 over 9 minus 7/2. Okay, so this is the one side, and hopefully it equals 5/6. Okay, that was the original problem. So let's hit enter. Gives me a decimal. I have no idea if that equals 5/6. So I want this to be converted back to a fraction. The calculator can do that. You're going to go to math, which is right under the green alpha key, okay, math. And the very first choice says frac. It'll turn it back into a fraction if possible. So you're going to hit enter on frac and hit enter again. Look at that. It is 5/6. So now I know that both sides of this equation balance. Nobody says that you have to physically show a check. You can do a check directly in your calculator like this, okay? And this is how you're going to enter and get back fractions. Okay, let's try another one. I would like to take two thirds x minus 2 equals 3/2 x plus 1/6. And I'm going to follow that two-step process again. I look at all of these denominators. I got a 3, I got a 2, I got a 6. The lowest common denominator that they all go into would be 6. Okay, because 3 goes into 6, 2 goes into 6, and 6 goes into 6. Would it be wrong if you picked 12? Not at all. Okay, any common denominator that you find, all right, as long as it is the real common denominator, will work. But 6 is the lowest one. So I'm going to take this whole side and multiply by 6. And I'm going to take this whole side and multiply by 6. Again, it might be easier for you if you put the 6 over 1. Now, some of you might be able to do this work in your head. I'm going to do the work in my head first, but then I am going to go back and show you where the straight multiplication comes from. Okay? 3 goes into 6 2 times, and 2 times 2 is 4. Okay, so I'm doing the division first, the canceling first. 3 goes into 6 2 times, and 2 times 2 is 4. 6 times negative 2 is negative 12, equals 2 goes into 6 3 times, and 3 times 3 is 9. So again, it's the division or the cross canceling first. 2 goes into 6 3 times, and 3 times 3 is 9. 6 goes into 6 1 time, and 1 times 1 is 1. If you feel comfortable doing that arithmetic in your head, you can jump from here to here, okay? You don't have to show any additional work. If you don't feel comfortable doing that arithmetic in your head, and that is okay, you're going to multiply straight across. So this is going to be 12 over 3x minus 12 equals 18 over 2x plus 6 over 6. Each of these fractions is going to simplify. 12 divided by 3 is 4, 18 divided by 2 is 9, and 6 divided by 6 is 1. Now I can do this problem with regular algebra. Take away 4x from both sides. Negative 12 equals 5x plus 1. Take away 1 from both sides. Negative 13 equals 5x. And then finally, divide by 5. And I get negative 13/5 equals x. There might be a situation where you're going to need to distribute a fraction first before you use this trick. So I'm going to show you one like that, and then we're going to call an end to this video. So let's say we have 3/4 x minus 1/2 equals 1/3 times 3/4 x plus 6 minus 7/2. I do not want to clear the fractions yet because I've got this multiplication to deal with. So first things first, I'm going to get rid of any parentheses. That's going to leave me with 3/4 x minus 1/2 equals, now I can cross cancel here, or I can just multiply straight across, right? That's up to you. This is going to equal, if I cancel 1/4 x plus 2 minus 7/2. If you need to do a pit stop before this, like I said, you don't have to do that in your head. This is going to be 3 over 12x plus 6 over 3, and that's where these two values are coming from. Okay, I'm just moving it straight down. Now I can look at this and say, all right, I want to clear out the fractions before I go any further. I only have 4s and 2s in the denominator, so the common denominator will be 4. multiply everything by 4. This is going to be 12 over 4 minus 4 over 2 equals 4 over 4 x plus 8 minus 28 over 2. Now, I didn't put it over 1, but you could just put it over 1 so you could see the multiplication straight across. This is going to be a nice 3x minus 2 equals 1x plus 8 minus 14. If you feel comfortable doing this math in your head, like I did in the previous problem, you always have that as an option as well. It'll take you right from here to here. Now I can combine like terms on the right side and then solve the rest of the problem. So take away 1x. That leaves me with 2x minus 2 equals negative 6. Add 2 to both sides. 2x equals negative 4. And last but not least, divide both sides by 2. And I get x equals negative 2. This will take a lot of practice, but it's a really nice trick for getting rid of all the fractions. All right, if you have any questions, please don't hesitate to ask, and I will see you in the next video.